All right, Mr. Ahmed here for 5.6. Goal for today is still proving triangles congruent. We're going to add two more theorems today, which is angle, angle, side, and angle, side, angle. So this is really going to wrap up all of the ways in which we can show triangles are congruent. So let's hop right in. Angle, side, angle states if two angles and the included side. So again, that included side is the side that's in between the two congruent angles, are congruent to two angles and the included side of another triangle. So if we have this going on for two triangles, then those two triangles are congruent. So the key, it has to be the included side. So angle, included side, angle. Angle, included side, angle. And then if I name the two triangles, triangle ABC would be congruent to DEF, corresponding parts. A corresponds with D, B with E, and C corresponds with F. So angle, side, angle. Our next one is angle, angle, side. So if two angles and a non-included side of a triangle are congruent to two angles and the corresponding non-included side of a second triangle, then those two triangles are congruent. So as I work my way around the triangle here, I'd have a congruent angle, and a congruent side. That's the corresponding side. Angle, angle, side corresponds. So as I work my way around, I went from one tick to two tick to the congruent part or side. One tick mark on the angle, one tick mark on the angle to the congruent side. So that's angle, angle, side. I'm going to name the first triangle ACB, switch it up a little bit. A corresponds with D, C with F. So DFE for the second. All right, so that is our last theorem. So I'm going to write all of them down right now. All the ways we can show triangles are congruent are angle, angle, side, side, angle, side, 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 angle, side, angle, and hypotenuse, leg. So keep in mind, if you end up with the swear word, angle, side, side, that's the no-go. Or the swear word backwards is also the no-go. All the other combinations work. So realistically here, if I have two congruent angles and a congruent side, the two triangles, for the most part, will end up being congruent. So here we go. Let's take a look here. As we work on these problems, keep in mind you have to look for additional things that you can mark. We can assume vertical angles. We can assume linear pairs. We can assume the reflexive property. I cannot assume right angles and things of that nature. So with this diagram, I see congruent angle, congruent angle, congruent angle, congruent angle, and we also would have a third congruent angle. However, based off that, I do not have a congruent side, so I cannot state that they are congruent, so they are not congruent based on the given information. They could be, but based on what we know, they are not. All right, next one, reflexive property, the side in the middle. So I do have a congruent side this time. Two tick marks, angle, angle, side. 2 to 1 to the side. This one is congruent by angle, angle, side. Next problem. Again, looking, I see the bow tie. With the bow tie, we have vertical angles. So these vertical angles in the middle are congruent, so I can add that in. And we would have angle, side, angle, and angle, side, angle. So that is congruent by angle, side, angle. The included side is congruent for both triangles. All right, next example says, state the third congruence that is needed to prove that triangle SAY is congruent to triangle CUE using the indicated positive theorem. So this one wants us to use side, side, side. All right, so we know that SA is congruent to CU, so that's one congruent side. We know that SY is congruent to CE, so I'm going to mark that. SA, CU, SY, CE. So for us to use side, 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 AY would have to be congruent to UE. If we had that third congruent side, then we could use side, 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 okay? Now, the next one says we're going to use angle, angle, side. So it says that we're given, I'm going to use a different color for this one so it stands out a little bit better. Angle A is congruent to angle U. Y is congruent to E. And it says that we need to use angle, angle, side. So we have some options here. I should have put 2 tick marks on this one. There we go. 2 and 2, 1 and 1. All right, so I could go angle, angle, side this way, or I could go angle, angle, side this way. So I'm going to say that if CU was congruent to SA, we could use angle, angle, side. You also could have gone the other direction and said SY would be congruent to CE. That would also be an option as well. So I'll include that one as an option too. You also could have said SY congruent to CE. Okay. Our next examples. Can STW and VWT be proven congruent with the information in the given diagram? If so, state the postulate or theorem that would be used. So this one's a little bit trickier here. I can kind of see that I have 2 triangles here. I have a 60-degree angle, I have a 90-degree angle, and I'm looking at this triangle here. So 60 is congruent to the 60 of the other. The 90 is congruent with the 90, and there's one shared piece for both of these triangles. The shared piece is the piece on the bottom. So that piece is congruent as well. So I do have right triangles. With every right triangle, you are not always going to use hypotenuse leg. Okay? So I see that I have an angle, congruent angle, the 90s and the 90s. So angle, angle, side is what we'd have to use for this one, not hypotenuse leg. The hypotenuse is here. We don't know if the hypotenuses are congruent based on the information that was given. All right, the next triangle, that piece in the middle is shared for both, so TW is congruent to itself. So I see angle, side, angle, and angle, side, angle. So yes, they are congruent, both of them, one by angle, angle, side, the other by angle, side, angle. And this one says, decide whether you can use the following information to prove that the triangles are congruent. So we forgot to state what the triangles were on this question. We have triangle ABC and triangle DEF. So I had to add that in. All right. So for this problem, since all we have is congruent parts, I would draw out a picture. I would draw just a random triangle and call it ABC, and then draw another one and call it DEF. Okay, we have to draw those out. So we know that angle C is congruent to angle F, as we are told. We also know that AB is congruent to DE, so AB, DE, putting tick marks on. This is how I'm going to see it. And BC is congruent to EF. So when I work my way around this one, I see angle, side, side. Angle, side, side is not valid, so they are not congruent. Okay, they are not congruent based off what we were given. We ended up with the swear words. All right, on to our next one, working on a couple proofs. So again, as we are working on these proofs, our last statement is going to have to be one of our shortcuts. It's going to be side, 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 angle, side, angle, side, angle, side. We have to end up with one of those to state that these triangles are congruent. So take our givens and see what we know. So statements on the left and reasons on the right. I'm going to start with a given, so I'm going to put that in right away. And my first given is M is the midpoint, so keyword midpoint of AB. So I need to use that midpoint. If M is the midpoint of A to B, I would then know that AM is congruent to MB. So that's my second step. I'm going to use that midpoint thing right away. Okay? So AM is congruent to MB. We used the definition of midpoint. Now I can go to my next given. If it's a keyword, use it. If it's a keyword, use it. If it's just congruent angles, move on to the next. So step 3, just congruent angles. Angle 3 is congruent to angle 2. I do need to mark it. Angle 3, angle 2. That's a given. There's nothing else I can do with that, so I'm moving on. Next step, step 4. says AC is parallel to MD. When we have parallel lines, we're going to use stuff from chapter 3. We're going to look for corresponding, alternate interior, alternate exterior. Typically for these problems, it's probably going to be alternate interior, so we're looking for the Z. So I need to mark AC as parallel to MD. And with that, I am going to highlight a Z and see what I can find if we have any alternate interior angles. All right, so let's take a look here. There's this one. There's this one. And we have a transversal here, but that's really not helpful. We also have a transversal here. So here's this transversal flying through. So with that transversal, I just don't see a Z that's all that helpful for us for this, other than, yeah, that's not really helping. So alternate interior wasn't it. What else do we got? Well, this diagram is super, super difficult to notice this, but with this transversal and these two parallel lines, angle 1 and angle 4, those are corresponding angles, okay? Angle 1 is above the transversal to the right of the line. Angle 4 is also above the transversal to the right of the line. So angle 1 is congruent to angle 4. And those are corresponding angles. So that was the corresponding angles postulate. If we had parallel lines, the corresponding angles are congruent, which we did. So now I can see that I have a congruent angle, included side angle, angle, included side angle. So the triangles are congruent by angle, side, angle. We get to finish the proof. And we can state triangle ACM is congruent to triangle MDB. Not gonna lie, seeing those corresponding angles was probably the toughest part. Probably won't see one quite that difficult on a test or a quiz. Might see one that hard on the homework. Alrighty, on to our next proof. So we need to show the triangles are congruent again. So we're gonna end with angle, side, angle, side, something along those lines. Our first given is angle 2 is congruent to angle 3. That's just congruent angles, so we will move to the next given right after we mark it. All right, angle 2, angle 3, those are congruent. We got it. All right, so our next given, step 2, this one has a keyword, bisect. So CF is bisecting an angle. So if an angle is bisected, we should get congruent angles. Which ones are they? So BCD is being cut in half. That's the angle on the top. That means these two little ones are congruent. So I have to name those with 3 letters. I can't just call it angle C. So angle BCF, trace it, B to C to F, is congruent to DCF. And we use the definition of angle bisector. All right, use the definition of the angle bisector. Now, I'm out of givens. I have to look at the diagram. What else can I assume? I can assume the reflexive property. The piece in the middle is congruent to itself. So I'm going to put a mark on that. Have to include it in the proof though. CF is congruent to CF. Reflexive property of congruence. And now I think I have enough information. Angle, angle, side, angle, angle, side. We got it. Our reason, angle, angle, side, we can now state that the triangles are congruent. Triangle CBF is indeed congruent to triangle CDF. That one wasn't bad. Just had to use that bisector term. All right, on the extra practice here, my recommendation here is that you hit pause and try these out on your own, and then you can come back and check your work, okay? So I would hit pause, try these on your own, and then come back to check your work. So, first one, are they congruent? I see side, angle, side, and side, angle, side. So yes, they are, side, angle, side. Now we have to make sure they're named correctly. So they named the first one A, B, C. ABC goes from no tick marks to 1, so I need to do the same on the other one. No tick marks to 1, so that's RWI. Example 2, angle, angle, side, angle, angle, side. So these are congruent by angle, angle, side. ABC again, so 1 tick mark on the angle to none. I need to follow that same pattern. 1 tick mark on the angle to none. So ESH. Okay. Side, side, side. 3 congruent sides. ABC. So when I trace ABC, 3 tick marks on the side to 2. I need to do the same. 3 to 2. So G, N, T. The way you name them is important. Corresponding parts have to go in the same location. All right, I see angle, side, angle. Angle, side, angle. The included side's congruent, so they're congruent by angle, side, angle. Now I have to name it GHJ for the first one, so GHJ, no tick marks to 2. Have to do the same, none to 2, so ARE. Okay, I see angle, angle, side, angle, angle, side. That's going to work out. And ABC is how I named the first, ABC. So that went from no tick marks on the angle to 2. So I need to do the same, none to 2, so DST. All right, next one. Side, included angle, side. Side, included angle, side. Side, angle, side. ABC. Let's see here. We're going 2 tick marks on the side to none, so I need to do the same. 2 tick marks on the side to none, so HEY. All right, next one. Again, I see another side, side, side. We have 3 congruent pairs of sides here for this guy, for number 7. Side, side, side. Name the first one ABC, so that's going 3 tick marks on the side to 2. Need to do the same. 3 to 2, so ILH. All right, angle, angle, side, angle, angle, side. I work my way around the triangle. Angle, angle, side. All right, angle, angle, side. First one's named DEF, so that's 1 tick mark on the angle to none. So 1 to none would be ASN. Okay, this one, side, included angle, side, side, angle, side. JKL, no tick marks on the side to 1. None to 1, so HAT. All right, 3 to go. Angle, angle, side, angle, angle, side. So the included, the non-included side is congruent for both, so we're using angle, angle, side. The name of the first one, ABC, so that's none to 2. Need to go none to 2 as well. Hold on here. Why is this not adding up? What did I do wrong? Well, angle, angle. I started at 2 here and started at 1 here. So this was not the corresponding side. So I really can't assume that that's congruent based off of that given information. So these ones are not congruent. Okay, because I started with 2 tick marks here, went to 1. 2 to 1 doesn't lead me to that same non-included side. So the corresponding side for the angle, angle, side isn't there. Can't use it. All right, next one, side, angle, side, side, angle, side. Or sorry, said that totally wrong. I pointed at it. Backtrack 1 second. Angle, side, angle, angle, side, angle. Got excited. So angle, included side, angle. Angle, included side, angle. They named the first one ABC. So A to B, I started here, went to there. So we had this tick on here. Have A corresponds with Y, so we have to start with Y. B corresponds with D, so we'd have to go to D, Y, D, E. So these last couple were a little bit tougher. All right, last one. Let's take a look. Angle, angle, side. S corresponds with M, so angle, angle, side. And they named the first one MNO, so that's 2 to none, SAK. All right, that's it for today. Have a good one.